So far we have covered product of powers and quotient of powers. So now we're going to address what happens when these two meet. So the objective of this lesson is to multiply and divide expressions in exponential notation. Before we go on, let's review each of these properties. So the product of powers tells us that if we find the product of two algebraic expressions with the same base, we can add the exponents and use this exponent with the same base. So the rule for this would look like this. So if I have a as my base, raised to the m power, multiplied by a again, so my bases here are the same, raised to another exponent, then I can add my exponents together and keep the same base. So my base stays a, and I'm going to add my exponents. Now my quotient of powers tells me that when you find the quotient of two algebraic expressions with the same base, you can subtract the exponent of the divisor from the exponent of the dividend and use it with a common base. So the rule for this would look as so. So if I have my base being a raised to the m power divided by a again, because my bases have to be the same, raised to the power of n, I can rewrite it as a fraction. So I would have a over m divided by a raised to the m divided by a to the n. Since my bases are the same, I am going to subtract my exponents as long as a does not equal 0. So let's combine these two properties in a few examples. Let's say that I have 4 to the second times 4 to the 7th times 4 all over 4 to the 3rd times 4 times 4 to the 4th. Now the first thing that I see is that I do have all of the same bases. Awesome, that's going to make my life super easy. So let's do the numerator first and then we'll do the denominator. So if I look, I have products. I am multiplying in each of these. So I know that I can use the product of powers, my bases are the same and they're being multiplied, to add all of my exponents together. So my base will remain 4, and then I'm going to add together all of my exponents. The same goes for my denominator. My bases are all the same and they're all being multiplied, so I can keep the same base of 4 and add together all of my exponents. Now let's simplify this. So that means that I'm going to take my numerator and I'm going to make that a little bit easier to look at. So I'm still going to keep my base of 4 and I'm going to add all that up. So 2 plus 7 plus 1 gives me 10. So I have 4 raised to the 10th in the numerator. In my denominator, I'm going to simplify, and 3 plus 1 plus 4 gives me 8. So I have 4 to the 8th in my denominator. Now I see that I have a division. I have a quotient here, so I can use my quotient of powers. And I know that my quotient of powers tells me that I can take the same base and subtract my exponents. I now need to simplify that. So I have 4 raised to the 10 minus 8, which is 2. Let's try another example. Let's say we have 1/4 raised to the 3rd times 1/4 times 1/4 raised to the 2nd, all over 1/4 times 1/4 times 1/4. All right, so again, the first thing I notice is that my bases are all the same. All of my bases are going to be 1/4. So let's look at the numerator first. Same as before, my base is going to be the same, so my base will be 1/4. And I still have my product of powers because they're being multiplied. So I can add all of my exponents together. Now let's look at my denominator. I see I have the same base of 1/4, and I'm going to add together all of my exponents. Now let's simplify that expression. In my numerator, I have the base of 1/4, and I have to add together all of those exponents. So 3 plus 1 plus 2 gives me 6. And then in my denominator, I have 1/4, and 1 plus 1 plus 1 gives you 3. Now I don't have any more products, so now let's take a look at my quotient. I know I can use my quotient of powers because I have two of the same bases. In my numerator, I have 1/4. In my base, I have 1/4. So my base of my exponent is going to be, of my exponential notation, is going to be 1/4. And I'm going to subtract my exponents. When I simplify this, I'm going to get 1/4 raised to the third because 6 minus 3 gives you 3. So there's really two steps to these problems. Step number 1 is going to be using your product of powers, looking at the numerator and denominator separately. Then step number 2 was simplifying the entire expression using the quotient of powers property. Let's try these steps in our last example. In this example, we are going to be simplifying the expression 3x to the 4th times 5y to the 5th times 6x to the 6th all over 2y times 3x squared times 5y to the 3rd. So our first step in a complex problem like this, we're actually going to regroup our numbers and then regroup the factors with the same bases. So this would look like this. So I have 3 times 5 times 6. So I've taken all of these and I've separated them from their variables. Now I'm going to regroup my factors with the same basis. So I see I have two x's, so I'm going to put those together. So I have x to the 4th times x to the 6th, and then I still have this y to the 5th. And that's going to be in my numerator. Now let's take a look at my denominator. So I have, these are my numbers, so I'm going to put those first. So I have 3 times 2 times 5. And then I'm going to regroup my bases. So I have x to the 2nd times, and then I have two sets of y variables. So I have y times y to the 3rd. Now I'm going to use step 1, and I'm going to simplify the numerator and the denominator separately using the product of powers property. So I'm going to rewrite 3 times 5 times 6 as 90. And then I'm going to use my product of powers to combine these two because the bases are the same. They both have a base of x. So I have x to the 4 plus 6. And then there's only one y, so I'm just going to have y to the 5th. That's going to be all over. So that's my numerator. Now I can look at my denominator. So I'm going to rewrite 2 times 3 times 5 to give me 30. And I only have one x, so I still have x squared. And then I'm going to combine my y's using the product of powers. So I have 1 plus 3. So that was my first step. Let's just simplify that before moving on. So we'll have 90 x to the 10th, y to the 5th, over 30 x squared times y to the 4th. Now let's look at step 2. We're going to simplify the entire expression by using the quotient of powers property. So the quotient of powers property says that if I have exponents that are the same base that are being divided by each other, then I'll be able to subtract my exponents. So let's rewrite this. So I'll have 90 divided by 30 times x to the 10th over x to the 3rd times y to the 5th over y to the 4th. So what I just did here is I broke them up into different problems so I can look at them each individually and use my quotient of powers property. So 90 divided by 30 gives me 3. Then I have x raised to 10 minus 2, because my bases here are the same, they're both x. So my base stays x, and then I'm going to subtract my exponents. And then here my bases are both y's. So I'll have y raised to the 5 minus 4. So just to simplify that, we have 3 times x to the 8th times y to the 1st. This is how you would simplify the expression and write your answer in exponential notation.